Well, good afternoon, everyone. My name is Jim Lake. I'm the Vice President of Training here at Viking Corporation. Today on Tech Talks, my guest is going to be Caleb Case. He's a Senior Product Specialist here at Viking. He's also the guy that when you call up the Viking, when we give you the technical services number at the end of this presentation, you'll be talking to Caleb too. You got a direct line to Caleb. What we're going to be talking about today is special sprinklers, as we've defined them and as NFPA 13 has defined them, and provide a kind of an overview of what they are, how they came to be, what they can do special, what makes them special, and then how they actually provide that a more efficient delivery of fire protection than perhaps using standard spray sprinklers in these areas. So we're going to cover that. We'll cover some other material as our learning outcomes are going to be. Let's see if I can get my. There we go. Our Tech Talk learning outcome. Caleb, come on in here. This is Caleb Case, and today we're going to discuss the requirements of special sprinklers, and we're going to discuss the impact of using special sprinklers on system design, and identify the resources and additional information on special sprinklers. And as I said, Caleb is the Senior Product Specialist. He primarily answers most of the calls that come into technical services. So we've driven this particular program off of some of those questions that you get asked. So we'll see how that all goes and how the questions go here. But to start with, NFPA 13 is actually the standard that kind of defines what a special sprinkler is, right? I mean, we have the standard requirements for sprinklers, and we've got this little section that talks about special sprinklers, right? And now sometimes when we get into this, we see that it defines it's intended for a specific hazard or construction feature. So that's the first definition of what a special sprinkler is supposed to be here by NFPA 13's standards. The second one is not only is it for a specific hazard or a construction feature, but it has to develop its own test protocols as well. It's evaluated and listed for performance under these following conditions that we got here on the screen. Where fire tests that are related, we have to build a fire test that actually is related to, looks like, performs like the area that we want this particular sprinkler to go in. Now, also distribution and of the spray pattern with respect to floors and walls, if that's what they have, that's what the space has, with respect to obstructions. And we evaluate the thermal sensitivity of the sprinkler and the performance under horizontal or sloped ceilings, and the design area and the allowable clearance to the ceilings. So all of those things kind of come into play when we do when we're looking at defining what a special sprinkler is. Now, there's a certain bunch of things here that we can't do, that we can't mess around with. We go with typical K factors, we go with typical temperature ratings, and then typical areas of coverage, depending on what we're going for here. So what I wanted to talk to you about is, we've listed three special sprinklers that we're going to talk about today, but let's take a look at these. Let's start off with what's not a special sprinkler and maybe why it's not a special sprinkler. So tell us a little bit about, if you will, let's explore just a little bit this institutional sprinkler. Now, the institutional sprinkler is kind of special, but why isn't it considered a special sprinkler?
So it's really designed for kind of special installations where they might require something different than just a regular frame style or concealed standard spray sprinkler. The institutional sprinkler, it's still going to go on. It's still going to be per the actual UL 199 testing for like a standard spray sprinkler or an extended coverage sprinkler. It's going to go through all those same tests. The only thing that's really special about it is how it's marketed. It's going to be more of a tamper resistant type of assembly, but it's really just a standard spray sprinkler.
Okay, so just a standard spray or sidewall, whatever it happens to be, but it's more about the occupancy that it's going into, right? I mean, it's all about kind of that space that it's protecting, not necessarily about any special spray pattern that it's developing or anything like that, right?
Right.
Okay.
Correct.
So the same thing would go here at the bottom. We've got our what we call our MRI, or our non-ferrous type of a sprinkler. Same deal there. I mean, it's evaluated under the same parameters.
Yeah, it's going to be evaluated under the exact same standard spray sprinkler different tests. The only thing different about it is it's using different materials to make it non-ferrous.
Right, to make it non-ferrous and make it safe to use in places like MRI, where MRIs
Yep, but
units are.
its fire protection doesn't change.
Right. Okay. So now that we've cleared this up, these are not necessarily special sprinklers. By definition in NFPA 13 or by the test parameters that we've set up in UL, that have been set up with UL. Let's talk about the ones that are. Let's explore these particular sprinklers here, and we'll start off with the coin sprinklers, or combustible interstitial spaces. So we know now that there's a lot of combustible construction going on in the U.S. now, and it's peculiar actually to the U.S. and Canada. A lot of places outside the U.S. and Canada, they don't use a lot of lumber in there, not the way we do in our construction. And as a result, we wind up with void spaces or combustible interstitial spaces between our ceilings and floors, or even above in the attic space, where there's a lot of lumber. There's a lot of wood that's involved in very small spaces. And NFPA 13 basically says, if you're sprinklering a building, you're also sprinklering combustible concealed spaces.
Yep, and the key word I think there is being combustible. So you've got those horizontal runs between the floors, even low pitch attics up to a 2 and 12 slope.
Okay, so that's something that we're going to talk about. Attic sprinklers later. Those are kind of a different animal. They're used under different slopes. So this can be used. What was that again? 2.5?
Up to 2 and 12 slopes.
Oh, 2 and 12.
Yep, so
okay.
low pitch.
Okay, low pitch roofs. All right. So let's take a look. First of all, this is a look here at the test fire that is run at UL for evaluating our sprinklers, our combustible interstitial space sprinklers. So the idea here is to be able to deliver water into these spaces with a spray pattern that can actually take into account the obstructions that are provided there and the narrow space, right?
Absolutely. So the idea is to develop this full-scale fire test and see how it performs.
So we've got the full test. So this particular little video here does kind of demonstrate what these spray patterns look like. Now, if I can protect, it's permitted to protect a combustible interstitial space with a standard spray sprinkler, right? I mean, that's not anything that the standard says, NFPA 13 says you can't do it with standard spray sprinklers.
Yeah, I mean, it's possible.
Sure.
But there are specially listed sprinklers like the coin sprinklers.
Yeah, and here's why they're specifically listed, because here's the spray pattern of a standard spray sprinkler in a combustible concealed space. Now, obviously, we've blown it up, but this is representative. If you went to scale, that's about 18 inches from the deflector down to that bottom cord. So we kind of spaced that out, scaled that out like that. And you can see that with a standard spray sprinkler, it's not developing a very big spray pattern to cover that area. We're going to wind up using quite a few of them.
Yeah, absolutely. They're going to be spaced closer together so that they can get that coverage.
Right.
Standard spray sprinklers really require about that 4-foot height distance before it can fully develop that spray pattern.
Yep. So what we were able to do a few years ago, actually, we developed what we called the coin sprinkler, the combustible interstitial space sprinkler, and that one we got to step out so we don't block this one. This has a much wider spray pattern now, doesn't it? Its whole intention here is to throw that water out at a very narrow spray pattern, a very shallow, very narrow, I guess is the best way to do it. Develop its spray pattern in a very narrow area.
Yep, correct. So we can actually cover between a 6-inch to a 60-inch space.
6 inches, 6-inch space. That's even difficult to get piping into sometimes. And this particular sprinkler, you can see if you measure down 6 inches in this, just kind of eyeball 6 inches here, that's got a very good very wide spray pattern compared to what the standard spray sprinkler was doing.
Yep, absolutely. Yeah, it's very unique. I mean, if you were to look at a coin sprinkler, you would notice it's got a very flat deflector, and that flat deflector kind of looks like a pendant sprinkler, but it's to be installed in the upright position. So sometimes that's the question that we get. They are specific applications, so they look maybe a little bit unique, but they're to be installed in the upright position too.
Okay, so let's take a look at that then. You were talking about that flat deflector. Actually, before we do that, this is the cool part of what it can do right here on this one. That's the activation of the coin sprinkler in that space. And you can see that it very quickly, because of its spray pattern and its capability to deliver that water, it very quickly knocked that down and passed the test that we developed. But let's take a look at the sprinkler itself. You said it kind of has an odd deflector for an upright sprinkler.
Right, absolutely.
So this is the VK900. This kind of our first go around at this type of a sprinkler, or because I know we have two lines. So the 900 came first. Or did we develop them at the same time?
They were really developed about the same time. So you'd have the VK900 with the VK950 with their initial listings, just so that we could offer a 4.2 K factor and a 5.6 K factor, which again are typical K factors, just depending on pressure and water supply.
Okay, great. So there is some, you can see here it's for, it can be used with wet and dry and pre-action systems. If you're going to use CPVC piping up in there, it has to be a wet system.
Yep. So they are listed with CPVC pipes. So I mean that
helps, and of course that helps in the residential kind of occupancies as well, or the hotels and things like that where they get built. But let's talk a little bit about this VK950 here, because the VK950 has some advantages that the 900 can't provide, right? That because of its smaller K factor and such, it doesn't have the same capabilities as the 950, which is our K56.
Correct. Like if you were to take a look at the spacing for the VK900, its head was underlined as 12-foot maximum.
Let's go back to that. Yep, 12 foot, 7 to 12, right?
Yep, exactly. So by using a little bit larger K factor with the VK950, we're actually able to get extended coverage spacing up to 16 feet.
Okay. So that's actually a considerable amount when it comes to trying to protect these narrow spaces. That really does kind of reduce the number of sprinklers that I have to put in these spaces.
Right. So and that's beyond the standard spray sprinkler spacing. So we're able to actually use less sprinklers.
Yeah. Great.
Instead of them being spaced every 10 feet.
Okay, so the other thing that the 950 brings along is and has its advantages. This concept of curtains, draft curtains, or I guess that's what they're called, is up there. And basically the construction, the requirements were before that we needed to have these draft curtains to separate off a certain amount of air, a certain spacing up in that space. What was that? 1,000? It started off at about 1,000 square feet.
Yep, for both coin sprinklers. So their initial listings, we're looking at 1,000 square feet, depending on the construction type, or 2,000 square feet, depending on the construction type.
Okay, and so that's kind of a pain in the neck for building contractors, because it's not the sprinkler contractor that's doing that work. They're just putting in the pipe.
Right.
It's the building contractor, and therefore the owner, that's paying for all of this and getting this in. It's a real pain in the neck to do that.
Correct.
So what do we have with the 950 that takes care of that problem?
Well, the 2,000 square feet, that enhanced listing, it was huge, because you're able to reduce the amount of material within that interstitial space. However, we went ahead and did some more testing with the VK950 sprinkler specifically, and we're actually able to, in many of the construction types, virtually eliminate draft curtains at all. So that reduces the cost of the project for the building owner.
Sure. So now you've got less sprinklers going in, which means less pipe, which means lower cost of installation. And then on top of that, the added benefit of not having to put in any of the draft curtains.
Yep,
so that
absolutely.
you're saving a lot of money with these sprinklers going in, which you wouldn't have with a standard spray or the smaller coin sprinkler.
Correct. Absolutely. Yep.
Any common questions, any challenges that you see that come in to cross the lines on coin in particular?
A lot of times I get questions about, well, do I require a draft curtain? So that's probably the main call that I get quite often. And it really comes down to asking a few questions. So I get asked the question, I have about 4 or 5 questions to reply to, which is interesting.
Tell me more about this space.
Absolutely. Yep. It's knowing the details about the space. So what type of construction is it?
Yeah.
Is it solid wood open wood truss? Is it solid wood joist or composite wood joist?
This is the one that can drive that discussion too, isn't it?
Absolutely. So my next question typically is, what type of pipe are we using? Was it CPVC like we've shown in the previous slide, or is it steel pipe?
Yeah.
And then the other driving factor is, how are your top cords?
Mhm.
Are they on edge or are they on face?
Right.
So that's a common question that I get too. What do you mean by on edge? What do you mean by on face? Well, we have them right there on the slide. So on edge, it's the long ways up,
Mhm.
and on face, it's the wide flat surface to the roof deck.
What's the impact? I mean, they look kind of the same. They look pretty much like they're wide open spaces. What's the difference, or what's the challenge with cord on edge as opposed to cord on face?
So cord on edge provides a little bit more of an obstruction to the spray pattern.
Mhm.
And it also allows the heat to kind of channel within each one of those truss spaces.
Mhm.
So it can delay activation of the sprinkler, and it provides more obstruction to the spray pattern. So by going on face, we're actually able to eliminate some of that obstruction, so you can get more spacing out of your VK 950 sprinkler. In some instances with it on edge, you might be limited to 14 feet as your maximum spacing to eliminate draft curtains. So you wouldn't require draft curtains at that spacing in some cases.
Okay.
If we have them on face, then we can go out to the full 16 foot.
16 foot. What if I stuffed insulation up and reduced that? If I put it between the edges up there on the cord on edge, can I mitigate that by putting insulation, or does that not really make a difference?
Insulation makes a big difference. So a lot of times you'll see non-combustible, like a rolled bad insulation held up with some kind of wire netting, and that creates that smooth lid.
Mhm.
So you're able to take advantage of the spacing then too and
There you
eliminate
go.
draft curtains.
Great, cool. The next one we're going to take a look at then is it's a similar space. It's a concealed space. It's not occupied. It's not occupied space like similar to the combustible interstitial space, and that is attic spacing, and combustible attic spacing in particular. And as we take a look at these, they do have similar characteristics to the interstitial space. Number one, they've got lumber, lots of lumber in them. I mean, it literally is another lumber yard up there, which also means that they've got some obstructions to the spray pattern, and they've got special, so they've got special needs there to kind of get the water around all of these obstructions as far as the trusses are concerned.
Mm-hmm.
And the other one is that it's a very unique feature. It's got this shrinking space that goes through it. Unlike a combustible interstitial space, which kind of remains flat, it might have a slight slope to it, as you were saying earlier. But these have a really shrinking space all the way out to the edge. Now, this particular video here is a test fire that we ran at our facility down in Hastings. And it's time-lapse photography, so it goes for about 11 minutes total as we go. But as you're looking at this, what are we noticing about the fire here that started out at the eaves and it's coming up into the space? What kind of characteristic are we noticing here?
Absolutely. So as you see the fire growth happening over time, it's actually staying within the channel and building up the slope towards the ridge.
Yeah, it's going like gangbusters up the ridge. That's the point. That's the path of least resistance for it. You see that counter growth isn't occurring at all. It's staying fairly narrow, and so even as we get out to now, we're probably out somewhere around 8 minutes or so in this. Even as it's starting to break out after 11 minutes, when this thing really gets going, it's only about 6 feet wide.
Mm-hmm.
It's only got about a 6 foot wide spray pen, and there it goes. It blasts through, but each one of those trusses are 2 feet on center. And so, okay, what are we to make of this? And what if we could, if I can protect this again, I can do this with standard spray sprinklers, right?
Mm-hmm.
13 doesn't say I can't do that.
Correct.
But because of the spacing and the slope, a lot of times it's a dry system, which we'll get to here momentarily. We'll show people here momentarily the impact of that. You're going to wind up with a very large design area with a lot of sprinklers potentially flowing.
Correct.
So what if we were able to deliver water out to that particular end of the, the eaves with maybe a single line of sprinklers. And that's kind of where we were going with the attic sprinklers. So tell us a little bit about, before we get, we got all these demonstration videos and they're really cool. We'll take a look at all the different spray patterns. But let's talk a little bit in general here about, just introduce us to the family here, if you will, and going across this one.
Right. So the really cool thing is attic sprinklers. Viking's developed quite a number of them. I'd say we have probably one of the largest families of attic sprinklers. So we can really suit just about any challenge in an attic with any one of our sprinklers. So on the top there, we've got the back-to-back, so the VBB, which is going to spray water to both sides and be positioned at the ridge and shoot water down each slope. We've got single directional sprinklers, which are going to spray a little farther.
This one right here.
However,
I'm going with the pointer here. I'm pointing. Look at me. I got it.
Yep, but they're gonna spray down one single slope. In the center there, we have the BEP sprinkler, so Eave's protection. It's actually a downslope sprinkler, which is pretty unique. It's a completely different design than using the back-to-backs or single directionals or our hip sprinkler here in combination with the attic upright. But the BEP can use the attic upright and cover wider spans, but also help reduce flows for low pitch attics. So that's a pretty unique sprinkler. And then we have the V-hip sprinkler here for your hip ends.
Yeah. So now that we've introduced everybody to them, let's see how they work and how they're actually well fit to deliver the water to the outer edges in this highly challenging environment in the building. So first thing is then, when you're ordering or when you're looking at this building, it's really important to know your roof slope, right? Because this is we've got 3 different ones all in this back-to-back range, right?
Yep, there's a couple different K factors. So we've got 5.6K and 8K. But we also have them unique shape to their deflector to the slope of the roof. So you can see the really flat one. We can go 4 and 12, and then it gets more angled all the way up to a 12 and 12 pitch roof slope.
So these are upright sprinklers, and typically in a sloped ceiling, the sprinkler deflector is intended to be designed parallel to the roof slope.
That's correct.
But that's not the case with these.
Correct.
Okay, so these are straight, vertical, always vertical installations.
Yep, they're going to be vertical in the upright position, and the deflector is going to do the work for you for its slope design.
So that's why it's important to get the slope, to know what the slope is, and get the order right, get the sprinkler K effect, because each one of these has a different SIN number to them.
Absolutely correct. Yep, each different spray angle and each different K factor, unique SIN.
Okay, so then let's just taking a look at this. We'll kind of step out of the way a little bit here, and this is what we were talking about as far as the throw. How far can this thing throw?
So this one specifically, we're looking at 40 foot and 60 foot spans when you're just using a back-to-back at the ridge.
Okay. So we got the back-to-back, and you can see also in the lower one, it's a very narrow spray pattern. So when it gets all the way out to the end of its spray pattern, how wide is that spray pattern?
So as far as the span, we can go 40 foot or 60 foot span.
Yeah, but how wide is the spray pattern itself when it gets to it's fairly narrow, right?
Yeah, our coverage areas, our spacings are 6 feet.
6 feet. That sounds familiar because when you go back into that video, remember the video had the fire growth, and by 11 minutes it was only 6 feet wide. Right. So we're going to be putting sprinklers every 6 feet down this, but only down the peak of the roof.
Yep, if you're using just a single line. Yep, with the back-to-back sprinkler.
All right. So the next one then is, and here's the cousin here, or the brother, or however you want to place it. It's the single directional. Now everything looks kind of the same here with the single directional. Here is that it's got the same pitches and it's got the same, same angles. Yeah. So this is also a vertical installation as well, upright only?
Yes, it is. Yep. So the sprinklers are going to be ordered based on the pitch of the roof.
Okay.
Could you do like a multiple slope? Sure. We could do a 4 and 12, 7 and 12 on one end, and maybe it's 8, 12 on the other. So if you had kind of a different slope, multi-slope roof, you could position single directionals that way as well.
Okay, so I'm coming up off of I'm coming up off that main line with what I'm just coming up to on either side of, and just there, or can I use them like really close back to back, or do I have to separate them somehow, or is it a?
Yep, so you'd actually separate them with a baffle, so they'd have a
Okay.
heat collection baffle behind them.
Mhm,
That way they don't cold solder each other.
mhm.
And then they can spray down a single slope and protect multiple slopes.
Okay, cool. So that's important then. If I've got multiple angles, if I've got differing angles on either side of this peak, salt box construction is sometimes what is referred to in New England anyway, because it's called salt box. We can do that, but you're going to wind up with two sprinklers up there separated by the baffle.
Yep.
And all right. That's interesting there. So let's take a look at this. We'll step out of the way here and we'll see the spray pattern again. Now, again, it's angled to, this is done over in our flow lab here at Viking. It's angled depending on the deflector, but it's also very narrow. So it really is like half of a back-to-back, right?
Absolutely.
It's just, that's really all it is.
Yep.
So it develops a narrow spray pattern at the end of it as well, right?
Correct, yep, so we're looking at the same spacings.
Mhm.
Really, the biggest difference is we're only throwing water in one direction.
Mhm.
So our throws or the span is a little bit further with just one sprinkler.
Uh-huh.
So unlike the back-to-back where you're looking at 40 or 60-foot spans,
Mhm.
we could do 30-foot or 40-foot in a single direction.
In a single direct, wow, okay. All right, now let's take a look at the hip sprinkler, because the hip sprinkler and hip bridges this is a really unique spray pattern that these have.
Absolutely.
Yeah, this has like the back to back. This one has a very unique spray pattern to it in that it's designed actually to spray at like a 90-degree angle, right? I mean, sprays come out of it at 90 degrees to go down each of the slopes from this hip ridge right here.
Yep, so it's not coming out straight, but on two angles.
Mhm.
And then they're gonna be kind of nested together at 6-foot spacing.
6-foot spacing again. How about that?
Yep, and
Yeah.
then these sprinklers at each angle, they're gonna throw up to about 28 feet.
So, yeah, so the nesting you were talking about is right, as you're going down that slope, each one of those spray patterns is nesting right into the other one's spray pattern. So you don't have a dry area there either.
Correct.
And to show you that then, we'll demonstrate this one a little bit further here. And you'll see that 90-degree thing, or that it's a little less than 90 degrees, obviously, but you can see the capability of that particular sprinkler. Now envision nesting another one down in front of it and another one down in front of that as you go down the slope. So the last one we'll talk about here, and we'll have to step out of the way again, but is the single directional and the EP is the Eave protection sprinkler, right?
Correct.
So talk to us a little bit about the differences here, because they kind of look the same. They have some of the same features, at least as far as the deflector is concerned, but these have very different installation rules that go along with them and different performance.
Oh, yeah.
So why don't you cover that in the EP and the SD here?
All right, so yeah, you can kind of notice they are a little bit different, but the deflectors look somewhat similar. We've got the
There you go.
single directional, the gap is pretty much closed, right?
Yep.
The EP deflector, it's a little bit more elongated.
Mhm.
And that's important because we're not actually using it at the ridge like the single directional. We're using it as a down slope sprinkler. So it's actually going to be positioned down the slope between the eaves and the ridge.
Okay. Now, the other one is, I gotta step out of the way again. This one, talk about that flared angle right there, because that's also different. They're different from the single directional, which has a real square deflector when it comes to developing its spray pattern. But we go over here to the EP and it's kind of flared out. What's the reason? What's the limits on that, or the reason for that?
That way it can throw that distance
Mhm.
and be able to cover that eaves.
So here's the distance you were talking about. On the right is the Eave protection, and on the left is the single directional here. They look kind of similar, but when you realize that the Eave protection one is actually supposed to be slow, is intended to be installed along the slope of the roof, right? I mean, that's kind of like any other sprinkler where the deflector is parallel to the slope. Whereas the single directional, if in other words, if we were to take the Eave protection one and angle that actually down the slope, we would see a dramatic difference in these two spray patterns.
Right, and it's actually, yeah, that's the intention, is it's gonna be installed on the slope or parallel with the slope as
Mhm.
well. And what was kind of unique, if we were to kind of look at those water mists, is on the single directional, if you look where the single directional is installed, and compare that to where like the bottom spray pattern of the eaves protection sprinkler, well, that eaves protection sprinkler, it sprays 24-foot throw in one direction, but actually throws 4 foot up back the other, so that water mist or cloud is a little bit bigger on the EP behind the sprinkler.
Wow. So let's take a look at the width of the sprinkler, of the spray pattern though, because this is what we were talking before. With that flared deflector, that's actually creating a wider spray pattern down the road. So it's not meant to be limited in its spacing. Right, similar to the way that the single directional is, right? Or does it have a wider spacing?
I would actually have to look, because I don't remember that one off the top of my head. They are
Okay,
specific application sprinklers, so
right.
yes, a lot of the times I'm looking at the data sheet myself too, because they are very different.
Yeah.
But I think it is a little bit different for the spacing. And when you space them, we're gonna use the eaves protection sprinkler in combination with the VK 697. So that 697 sprinkler and the eaves protection, they're actually staggered. So that
Okay,
width
they're
helps with
covering-
the staggering as well.
They're covering a lot of space. And this is where you lead into that perfectly. You lead into that perfectly. So we're going to give you an example of how the use of the Eave protection sprinkler and the use of an attic sprinkler actually can get you out to 100-foot span in the roof. So, and how that, and we're going to show you now how it describes how that particular one saves a lot of money in the design based on a standard NFPA 13 design here. So let's just take a look at what we got here. I got a building here that is 100 feet wide. I'm protecting it with 9 branch lines, and those 9 branch lines are, by the time we take into account a 1,500 square foot area, and we take into account a 30% increase because it's a dry system, and we take into account another 30% because it's a sloped ceiling, we're up to a design area over 2,500 square feet. And in order to cover that, I need to do 21, I got to calculate 21 sprinklers into this at 14.8 gallons per minute, or over 300 gallons per minute total demand in the attic. So that's that. Now talk to it now. So I've made my case. This is how the NFPA 13 handles it. And I'd like you to make the case as to exactly how our combination of the EP sprinkler and the attic upright listed together, right? Because they were tested and listed together, are actually going to drop it from 9 to 5 branch lines. So go ahead.
Right.
We'll let you rip on that.
All right, so you notice the design area here is gonna be in this gray shadowed box.
Mhm.
So we've got six sprinklers in that design area. And notice that they're a little bit different symbols. So we've got attic uprights, specifically the VK 697, that's gonna be spaced at the ridge. And then staggered on that spacing, we've got the VEPs, which are down the slope. And then notice we have another line of sprinklers at the eaves, which again are BK 697s. So the combination of attic uprights at the ridge, down slope, and then more attic uprights, we're able to get to that 100-foot span, which is pretty interesting because we're actually able to provide a low flow attic design.
Mhm.
So notice it's 6 sprinklers at 20 GPM, total 120 GPM. That's a big difference between the 311 that we saw on the previous slide.
So, but we have to do 2 counts, right, to prove this out in order to make this work. We have to, and I'll step out of the way here.
Yep.
Tell us about this. What's the difference here?
So basically we have 2 designs and we're looking to design it for the most hydraulically demanding design. And we have to do 2 calculations to prove that. So we had 6 sprinklers at the ridge, the most hydraulically demanding attic uprights. And then our other calculation is 4 at the ridge with the uprights and then picking up 2 downslopes.
Okay. So given that, here's what you wind up with. Here's basically the totals that you wind up with that. If you do the NFPA 13 design with just standard spray sprinklers, you wind up with not only more water, but a lot more pipe and a lot more installation costs going into it, as opposed to this lower flow and lower flow basically, and lesser number of sprinklers actually flowing. So
Correct.
It's a great savings, more than 50% on the demand of the system.
Yep.
So
One of the other nice things too, using the attic sprinklers is that we're now able to cover with the coin that we covered already earlier, 0 to 2 and 12. And then with the Eave's protection sprinkler, we can cover down to 2.5 and 12, all the way up to 12 and 12.
So the full range, we've basically got the full range covered depending, regardless. Any hot questions that you usually get, common questions on the attic sprinklers that you want to go over or anything like that?
Yeah, absolutely. There's a couple that I get occasionally, in addition to what we've already covered.
Yeah.
One of those questions is, can I use the attic upright sprinkler all by itself in an attic? Instead of using, like you would a standard spray sprinkler.
Sure.
The answer to that question is no, you can't. They aren't specifically listed to be used by themselves. They are a sprinkler that's listed in combination with our other sprinklers. So
Okay.
you could do a low flow design. If
Right.
you're using BK 697s, then you would have the VEP.
Yeah.
Otherwise, it's the back-to-back, the single directional and the hip in combination with the attic upright. And it's really designed, one, we can get the low flow design, or we're getting around obstructions.
Right. I was just about to ask about, you can use the attic sprinkler in combination. You said it, in combination with the back-to-backs or the single directionals, when you have obstructions out there beyond was it greater than 6 inches, I think, in one dimension.
Yeah.
That it actually, you're required then to put something on the other side of that obstruction. And it could be a standard spray, but it could also be the
attic upright, absolutely. And you would have to, of course, look at the data sheet and include those additional sprinklers around obstructions in the hydraulic calculation.
Sure. Yeah. Oh, good point. If you've got sprinklers out there, you do have to account for them.
Yeah, absolutely. There's another common question. It's kind of an interesting and a cool concept, but it's not anything that we've tested for. But can attic sprinklers be used in like open gymnasiums or churches? Something to that effect.
Oh, something that represents the same slope of the ceiling, but there's nothing underneath it. It's not a concealed space. There's stuff underneath there.
Correct. So it's a specific application sprinkler using the attic sprinklers. So they have certain criteria laid out in UL. So the standard is going to call for a roof. It's going to have trusses or joists. Trusses. And then it also requires to have a ceiling below it. So the actual testing is using a wood ceiling that we had seen.
So the geometry of the way we test this, it has a bottom, it has a floor, and it's a triangle basically.
Basically a triangle.
So so no, you can't use it down to the floor, because you got to remember, when we're protecting churches and gymnasiums and things like that, it's all about what's on the ground, what's on the floor that's burning, and you got to be able to deliver that kind of density down there.
Correct.
Not to say that we couldn't do it, we just have never, it's not been explored like that.
Right. They're specific application for a reason, where we're trying to put a fire out in an attic, not necessarily trying to provide the proper
coverage,
area density coverage for the floor space below.
Perfect. Okay. All right. Last special sprinkler then that we're going to talk about here is the window sprinkler. And I've often said that the window sprinkler really, it sprays water like a sprinkler, but it really doesn't, it doesn't do the same things that our ceiling sprinklers do. It's really got a very unique operation. It's got a very unique goal when it comes to fire protection, and it's not putting the fire out. The other thing that comes into play here is that it's not just about what we can do here. There's a couple of different ways we need to get approvals. We need to send it through UL and go through that testing. But then in order to be used as it's supposed to be used, which is exposure protection for glass, it needs the additional approval of the codes, basically the ICC, to get into the building code to provide that separation.
Yep.
But here's what we were talking about here. This sprinkler is not designed to spray any water on the fire. That's the job of the ceiling sprinklers to do that. This one is basically trying to spray, is intended to spray and maintain the integrity of glass in a fire rated separation, right?
Correct.
Okay.
Yep. Basically, the sprinkler is trying to provide that, or does provide that fire rating equivalency.
Right. And so when it comes to examples as to where this might work is we're trying to put, the building code says things like if you have a multiple floor opening go through the building, you got to protect that. And a lot of times what they'll do is, you can build a solid wall around an atrium, but it doesn't really look like an atrium anymore, just like a big hole in the building. So architecturally, architects love glass. They love to use glass to give that open feeling. The only problem is glass doesn't really resist fire very well. So whether it's down a glass corridor and maybe this is an exit passageway, or it's separating an atrium, it's just not really, it's not as good as a block wall or sheetrock wall. So let's look at this spray pattern. Tell us what the window sprinkler is, what's unique about this and what they're seeing on this spray pattern.
Yep. So basically, this is a test or a spray pattern that we've flown in our flow lab. And as you can notice, we're getting a nice even sheathing or that coverage of water over the entire surface of the glass. Basically, it's there to cool the surface. It's going to cover completely from top to bottom. That way that there's no dry spots. So that's what I mean by that even sheathing of water. And that eliminates those dry spots where fire could potentially crack or spread the glass.
Right. So the testing, the heat source is right next to the window, right? We're blasting the window with the heat source, and then we're cooling it with this particular spray pattern by its sheeting down, what you're saying. So even if I have a small area that's not getting the sheeting of water, that could actually be a space that causes failure in the whole window system, right?
Absolutely. So we're not really trying to put the fire out with the window sprinkler. We're trying to contain it so that the sprinklers in the room can take care of the fire in the room.
Right. So we're maintaining the tenability. We're maintaining the tenability of the space on that with that particular sprinkler. So we're maintaining the fire resistance rating really of the window. So a couple of rules then that come along with this. Now, what's really important with this is as it's getting evaluated, if you're planning on using these types of sprinklers, there's other rules that come along with this that in order to make this sprinkler successful, you also have to pay a lot of attention to the glass that's going in.
Correct.
Right? You have to pay a lot of attention to a couple of things that come up here. So let's talk a little bit about that. I mean, quarter-inch thickness.
Yep.
And heat strengthened tempered glass and single or dual panels.
Correct.
Right. So again, that's just the glass itself.
Yep.
Then we get into talk a little bit more about these two requirements here. This one here.
Okay. So basically you're limited to a window that's 13 foot in height, so we can't exceed that maximum. And then you could go, so there isn't a limit on the width, just like it shows on the notes there.
Yeah.
So the only limit is going to be whatever the building code determines. So you can go as wide as you would like.
Now, pony walls.
Oh.
Yeah. What about pony walls? Are pony walls included in the 13 feet, or how do they come into play? Can you comment on that one?
Sure. So pony walls really come into play when they're required if you have maybe something combustible near the glass. So you have to be at least 2 inches off the surface of the glass, and then you would come up with a 3-foot pony wall.
Okay.
And that helps maintain the integrity of the glass as well.
Yeah, because sometimes you got fuel burning, you have the potential for fuel burning right at that. Yep. So they require a solid pony wall coming up on top of that.
Right.
Okay. All right. Must be vertical and cannot be sloped or curved. Why not?
Really, to provide that even sheathing, it's got to be a vertical, straight up and down type of glass.
Okay. So if it was, yeah, I guess if you're trying to spray under something that's not vertical, it's gonna be dripping down off it. And if you've got a curve, it's just not gonna deliver that evenly as we saw before. It's gonna miss some spots. It has potential.
Yep, it has potential to create maybe some dry spots, or
Mhm.
maybe you don't get enough sheathing to help it cool
Okay,
to where the glass could, or the water could evaporate off the glass.
great. All right. Now, mullions.
Well, yeah,
Let's talk a little bit about mullions. The only ones that are permitted are vertical.
vertical,
mullions, right?
absolutely.
The obvious challenge here is if you have a horizontal mullion, that's gonna stop everything. So I guess if I had a horizontal mullion, I would wind up with another sprinkler down below it. No.
Actually, that's not allowed.
Oh, it's not allowed.
Yep, so,
Oh, all right.
so you have to have a, yeah,
Tell me
yeah,
more.
you have to have a single level, so no horizontal mullions. If you happen to have a horizontal mullion, that bottom glass either has to be fire rated,
Mhm.
so it's gonna be a little bit more expensive glass,
Yeah,
or you
yeah.
create that pony
Or you
wall,
create
lose
the
some of that
pony wall.
light.
Okay.
Yep.
There you go. All right. No operable windows, only non-operable fixed glazing. So
Yep.
you can't penetrate this.
Correct, yep.
It kind of defeats the purpose anyway.
Yep, it's very specific to fixed glazing, because if the
Mhm.
window's open, we can't cover it.
You can't cover it, right? And then when it comes to penetrations, that's another thing that's always a sensitive area around firewalls anyway. Fire barriers and things like that. Anytime you penetrate, they're perfect until you start penetrating them. And that's not just glass, that's any firewall. And that's why they have the requirements that they do around any kind of penetrations, fire sealing and things like that. Well, it's not gonna be the same way with glass. So what we require, no penetrations of any kind. We're not messing around with any penetrations through there. And then any openings like the door in this particular wall would have to have its own fire resistance rating, just like everything else.
Correct, absolutely, yep.
Okay, now, here's the advantages, and we're gonna talk about the vertical sidewall and the horizontal sidewall and the differences there. I want you to expand on the differences here in the two sprinklers and how they provide extra benefit depending on which one you choose, especially, I think it's the horizontal. No, it's the vertical sidewall that
Vertical.
provides that little extra benefit.
Yeah,
So talk to us about these two and the vertical sidewall spacing and the horizontal sidewall spacing.
so these are actually figures taken right from our sprinkler data sheet. So most of the information that we've covered so far is either in the data sheet or in our ICC evaluation report.
Mhm.
So it should be easy to find. If we notice, kind of closer towards Jim, we've got the pendant vertical sidewall, and it's showing the spacing. So the spacing for the vertical sidewall is 12 foot. So you can space them out 12 foot between the sprinklers, which is a key advantage.
Okay.
Prior sprinklers, the spacing was 8 foot.
Mhm.
Just like our horizontal sidewall installation there that's shown, that is still an 8 foot max.
Still an 8 foot
But the
max.
vertical sidewall, a little bit different look,
Mhm.
out to 12 foot.
Wow. Okay, that's an advantage. Now, finally, you take a look at this too, because each one of them, it's important to know that each one of them has different spacing requirements though, away from the glass, right? I mean, it's just, depending on which one you're using, you can see that there's distances below the frame that need to be maintained from that top frame. And then there's differences between the 4 to 12 separation from the glass itself for the vertical sidewall, as opposed to half inch to only 4 inches for the horizontal sidewall.
Yep, and kind of address one of your questions earlier about the 13-foot height plus the pony
Right.
wall.
Mhm.
Notice here on the figure, it says no maximum height for that space,
Right,
but you have 13 foot of glass. So if you want to go higher, you can, you just have to have either a pony wall or fire rated assembly.
okay. So on top of that then, I'll go back to this. Any hot button items that you get so far with these, or are these pretty self-explanatory? What are the questions that you get? Do you get any?
The nice thing with the window sprinklers is they are quite specific, so usually the answer is right in the ICC report, if you can't find it on the data sheet, which the answers are really in the data sheet as well. So I don't get too many questions other than, do I require sprinklers on both sides of the glazing?
Oh, okay. Yeah.
Absolutely, yes, you do. So, In order to have that 2-hour equivalency, sprinklers are positioned on both sides.
Positioning them on both sides, so that's great.
Yep.
But you also mentioned there that what's really important here is that evaluation, the ICC evaluation services report. And we didn't really talk about it. We said they needed to approve it, but we never really mentioned
Sure.
how you get proof that it's approved, right? How someone would know that this sprinkler was approved like that. So it's an actual document,
Absolutely.
and we have it.
Yep, you can actually, yeah, it's on our website,
Mhm.
right next to the data sheet. So
Okay,
you can pull up the data sheet, you can go into approvals or certificates, and it's also going to be right there with the ICC report. You could also go to the ICC's website if you wanted to and look up the different evaluation reports. But again, it's full-scale fire testing, and
Right.
it's been evaluated by the ICC. So it's got both the UL listing and the
and an
approval.
ICC
Yeah.
approval.
Yep. There was kind of one other question too that I typically get. Could it be used as an open sprinkler?
Mhm.
Absolutely. So it can
Okay.
be used, in a deluge application, be open, or it could be closed, an automatic
Mhm.
type sprinkler where it's got the element installed. So either way is an option, and that's laid out on page 4 of our data sheet in the UL design criteria.
All right, so in closing here, we'll just take a look at, here's Viking Technical Services. This is going to get you to Caleb, everyone. Caleb answering the questions for you. And the phone number, 877-384-5464, that's our technical services number. But again, what's really important with the special sprinklers, and in closing with the special sprinklers, is this additional documentation we've been talking about. It's either an FM approval report, it's a UL report on its listing. NFPA 13 for either attic or coin or interstitial or even windows, very minimal mention of any of these types of sprinklers. So you need to go, and then additionally with the window sprinkler, you're going to the ICC. And most importantly, we're going to the data pages.
Yep.
Data pages, data pages. The first question that Caleb's going to ask you is, have you downloaded the data page? Let's talk about that if you got some questions. So yeah, that's going to be key. So let's look at the data page together. The other one here, you want more information on this, or you want to watch this particular Tech Talk or any other Tech Talks that we have, go to our training tab, Viking Group Inc. /training.com, where you can get you can access the customer learning portal, which also accesses you have access to all of these Tech Talks, as well as a growing number of other training materials that we put together here at Viking. So I want to take this opportunity then to thank Caleb for his time and expertise in sharing with us the special sprinklers today. And we look forward to seeing you all on the next Tech Talk next month.